You have a little bit of idea. What is the idea of the limit? Limit means what? We will discuss it now. How to find the tangent line. Now I can teach you a little bit. Let's start limits. Without limits means no calculus. That's why the first topic of discussion in calculus book is limits. Let's answer to this question. What does the function do as the value of x approaches to a given value or number? What does the function do as the value of a, actually let's name it a, approaches to a given value? If we can answer this question, that's the idea of the limit, correct? I will explain it in an example for you. And actually, this is the meaning of the limits in algebra in calculus. What does the function do when a value of a approaches to another value? Actually, we are looking to the behavior of the graph, correct? That's the idea of the limit. You see, point Q is approaching to point A. What does the function do? That was the question in the tangent line, correct? That's the idea of the limits. For the few first examples, you will not maybe see the limit sign, but after few examples, when I slowly start teaching you the laws of the limits, maybe you see the symbol of the limit. Let's start with the first example. I'll explain everything here for you. For example, if f of x is equal x squared, what happens as x approaching to 2? Right? A function is given to you, f of x equal x squared. What happens if x approaches to 2? Let's see. This is actually a limit problem. To answer this question, I need a table. I will draw a table like this. Here I will write x, here always f of x. This number 2, I always put it in the middle. Whatever this number is, as x approaching to our number a, right? Always put it in the middle. Approaching to 2 doesn't mean that your point goes on the top of 2, right? I told you at the beginning that Q cannot be equal to P. That's why I'll block here. Now, choose, for example, 3 values less than 2, but really close to 2. And also from the right side, choose 3 values, which is very close to 2. For example, I'll start with 2.5. Then I'll put here 2.01. Then I'll put here maybe 2.001, which is really close to 2. From the left side, maybe I'll start from 1.5. Here maybe 1.5 let's say 0.9, and here maybe 1.999, or maybe here 1.99, correct? And here 1.999, really, really close to 2. Let's plug in these values from the right, and let's plug in these values from the left in our function and put the value of f of x, or let's find f of x for all of them. I'll do one of them as an example for you. You have a calculator, use your calculator. F of x equals, if you plug in 2.5 in your function, it means 2.5 square, which gives you 6.25, right? This value becomes 6.25. If you plug in 2.01, let me turn on my calculator, 2.01, and you square 2.01, it gives you 4.0401, 4.0401. And if you plug in 2.001 in your function, 2.001, and you square it, what happened to my calculator? 2.001, and I square this, it gives me 4.004001, which is really, really kind of close to 4, right? Also, from the left side, if you plug in 1.5 in your function, it gives you 2.25. If you plug 1.99, let's see how much is. I didn't plug before. I don't have a 3D. 1.99, and I square 1.99. It gives me 3.96. 9601, right? And if I plug 1.999 and I square it, it gives me 3.99. 3.996, which is really, really close to what? Which is really, really close to 4. Look at the right side. As the value of x approaching from right, please focus here. When you are approaching from the right, 4.004 is really close to what? To 4. And also when you are approaching from the left, 3.996, even if I put here another 9, go a little bit more closer to 2, but not equal to 2, it gives me 4, correct? Then I can say, based on this evaluation or based on this estimation, that the limit, I'm sorry, I'm writing limit like this, but you should write limit always like this. This is the symbol of the limit, the actual one. I don't know why I'm using this. I'll write my limit like this. If you see, this is my limit, correct? The limit of x squared as x approaching to 2 gives you what? Based on my estimation, it gives you 4. Correct? Let me show this example in a graph for you. 1, 1, negative 1, 1, because I want to graph y equal x squared. 2 and 4, and negative 2 The graph is actually a parabola, right? In this example. You see, when your x is, for example, you choose the first point was 2.5, right? You start from 2.5. You are going closer and closer to where? To 2. When you are approaching to 2, just watch my cursor here. You are approaching to 2. Move the cursor. I'm moving cursor to 2, which is this point. How much is the height of the curve here? How much is the height of my curve? You read always the height from the y-axis, right? How much is this point? This point is 4. When you are moving this way, let me change the color. When I'm going from the right, closer and closer and closer and closer and closer to 2, when I reach to 2, very close to 2, how much is the value of, or the height of this curve? 4. Also, when you approach from the left, from this side, look, I'm moving my cursor with the red line. I'm going closer and closer and closer and really, really, really close to 2. Again, read the height of this point. The height of this point is 4. Correct? This is the idea of the limit. When a point is approaching to another value, what is the behavior or the value of the function? Correct? This idea, we call it limits. Now, some notes. In general, you can say that, let me write in general. If you have the limit of a function, any function, f of x, and your x is approaching to a number a, it always gives you a value which we name it L here as a general form. This is the idea of the limit. Now, what does it mean? I'll write here the translation for you. How to read first. We say the limit of f of x. This is how you read this. The limit of f of x as x approaches a equals n. This is how you read this. The limit of f of x as x approaching to a equals what? L. It means, what's the meaning? You see, I'm even writing today a lot of notes for you. If we can make, very bad writing, if we can make the values of f of x arbitrary close to L, what does it mean? It means as close to L as we like, as close to L as we like, by restricting x to be sufficiently close to A on the either side. Let me put another parenthesis. On the either side, from the left or from the right, right? On the either side. But not equal to A. That's the meaning of that limit. You move your x really close to a number A on the either side, from the left side or from the right side. But you should reach to the same number. That's the idea. You cannot reach to a different number, to the same point, from the left, from the right. That's the idea. It gives you a number that's the value of your function, and we call this process the limit. Correct? The first method that you see a table, this is the method of guessing. You solve the limit problems using a table. But soon, tonight, or maybe in the next lecture, I'll give you the laws of the limits, which is really easy. You can solve a problem of a limit in few seconds or few minutes. It gets really easy for you. But for practice, to get the concept of the limit, let's do few problems using the table, correct? Example number 2. Find the limit of x minus 1 over x squared minus 1 as x approaching to 1. Find the limit. How much is the limit? Remember, the idea of approaching from the right to the point and approaching from the left to the point. Later, I'll explain something to you that a limit can exist if the limit of the left side and the right side are equal. Later, I will tell you this definition also. But for time being, make a table like this. Here always x, here always f of x. This number that your x is approaching, which in this example is 1, put it in the middle. Block this area because you cannot put equal to 1, correct? You're going really close to 1, but not 1, correct? Now, 2 3 points on the right and 2 3 points on the left. If it's 1, let's start from 1.5. And remember, this is a number line. You cannot put 1.5 here, 1.001 here. It should be in order, right? 1.5, for example, choose 1.01. For example, here 1. Let's say 001, very close to 1. On the left side, here, start with 0.5, maybe here 0.99, maybe here 0.999. Correct? If you plug in 1.5 in this function, I'll just put one of them, then the rest I'll just fill these numbers here, but you can do it at home with your calculator. If you plug in 1.5 in this, you get 1.5 minus 1 over 1.5 squared minus 1. And if you simplify this calculation, it gives you 0.4000, correct? 0.4000. If you plug in 1.01 in your function, it gives you 0.497. If you plug in 1.001 in your function, it gives you 0.499. Also from the left side, if you plug in 0.5 to this function, it gives you 0.666. If you plug in 0.99, it gives you 0.50, I think, 2. And if you plug in 0.999, it gives you 0.5002, which is really, really close to 0.5. 0.499 is also really, really close to which number? To 0.5. From the right side, 0.5. From the left side, 0.5. Then the answer for this problem is the limit as x approaching to 1 of x minus 1 over x squared minus 1 is equal to what? To 0.5. You solve every single problem of the limit. At least I assigned few homework problems of this section using the table or using the estimation. Later, we jump to formulas and it gets really easy to use a formula and solve a limit problem. Next discussion is one-sided limit. What is one-sided limits? Let me graph something here for you to explain the idea of one-sided limits. Example here at point A, maybe I have a graph like this, and here I have another point and another graph, whatever this curve is. Here X, here Y. One-sided limit. You see, what is one-sided? The limit you can see in this graph very, very easily. If you move from right side, correct? If your value, if your X moves from right or approaches to A from the right, look at my cursor. It goes really, really, really close to where? To this point, right? How I will write this in terms of the limit of right-sided, I will write limit as X approaching to A. How to denote from the right? You use a plus sign on the right side of the A on the top, not on the bottom. It means your X approaching to A from the right. The limit as X approaching to A from right of f of X of this function. How to write the left side? You write limit as X approaching to A from the left, from this side. You use a minus sign on the top of your number. it means you are approaching to A from the left of a function f of x. Correct? Now, let me graph a problem and let's discuss this problem. For example, let's say here 2. This. Now, if someone asks you here, find the limit of f of x as x approaching to 2 from the right side, how you will answer this question. It's one-sided limit, right? Find the limit of f of x. F of x means this function, this graph. This graph is your f of x, both of them. It's looking like a piecewise defined function, correct? As x approaching to 2. Again, focus on my cursor. When I'm moving from the right, like this, approaching to where? To 2. How much is the height of this point? The height of this point is how much? 1. Then the limit of f of x as x approaching to 2 from the right is how much? 1. Or they can ask you, find the limit as x approaching to 2 from the left of f of x. How much is that? Now you see, you're moving from the left. Look at how my cursor is moving. I'm approaching to 2. I'm going closer and closer to 2, right? I'm approaching to 2. How much is the height of my cursor? When you read the height, you always read it from the y-axis, correct? How much is that point? Negative. This is the idea of the one-sided limit. Now, a note. This note is really, really important. Let me put here even note. For the limit to exist, at a point A or at A, which we denoted like this, the limit of f of x as x approaching to A, it gives you L, you must have the limit of f of x as x approaching to A from the right equal to the limit of f of x as x approaching to A from the left. If you don't have this condition, the limit doesn't exist. In order that a limit exists, the limit, it means the limit of the left side and the limit of the right side should be equal to each other. If they are not equal, then you say the limit doesn't exist. Let's practice this note with few examples. Remember always this definition. The limit exists only and only if the limit of the left side and the limit of the right side, they're equal to each other. Let me draw another graph for you for this example. Again, in this example, I choose 2. I don't know why. Here 1, for example, here 2, here 3. I have part of the graph here, and I have whatever the shape is. The shape is not important. This is the shape of the graph, and here is 0.2. The question is asking you, for example, this function is g of x. They are asking you, find the limit of g of x as x approaching to 2. To answer, to find this equation or this limit, you have to evaluate the left side limit and the right side limit. It means you have to answer first these two questions. You have to find the limit of g of x as x approaching to 2. From the left, you have to find this, and also the limit of g of x as x approaching to 2 from the right. First, you have to find these two to can answer the question, which is they're asking you find the limit of g of x as x approaching to 2. Let's start with this one first. Limit of g of x as x approaching to 2 from the left. Again, I'm changing the color of my cursor. I'm approaching to 2 from the left. Here, I'll go close to the left, to the 2. How much is the value of this point? If you read it on the y, it gives you 1. Correct? Now, limit of g of x as x approaching to 2 from right. Look at my cursor. I'm approaching from the right to 2. Maybe you ask why you are not approaching here. Do you see any graph here? I cannot move my cursor here because there is no graph here. My cursor should move on the graph, correct? My cursor is moving here. I'm approaching from the right to 2. How much is the value of this point? 3. Now, question. Is the limit of the left-handed and right-handed, they're equal to each other? Can I write the limit of g of x as x approaching to 2 from the left is equal to the limit of g of x as x approaching to 2 from the right? No, they are not equal. And if they are not equal, what is the answer of my question, which they ask me find the limit of g of x as x approaching to 2? My answer is does not exist. D and E does not exist. Why does not exist? Because the limit of the left and the limit of the right, they are not equal to each other. That's why you are saying the limit does not exist. Correct? One more example. Find limit of f of x as x approaching to 5, and I'll draw a graph here. This is your function f of x. To evaluate, to find the limit of f of x as x approaching to 5, you have to first evaluate or find these. Limit of f of x as x approaching to 5 from the left, you have to find this. And also limit of f of x as x approaching to 5 from the right. You have to answer first these two to understand if this limit exists or not. If exists, how much? Again, changing the color. First, when x approaching to 5 from the left, look at my cursor, the yellow line. I'm approaching to 5. How much is the value of this point? 3. When you are approaching from the right to 5, how much is my value again? 3. You see the idea that Q is approaching to P. I don't care about this point. This point is not on the function. My concern is about this point. When I'm approaching to 5, how much is the value of this point, correct? Or the value of the function on the y. Now, what will be the answer for the question? Then you can say, because the limit of f of x as x approaching to 5 from the left equals to the limit of f of x as x approaching to the 5 from the right, then the limit of f of x as x approaching to 5 equals to how much? To 3. That will be your answer. Very easy. The idea of left hand and right hand limit is really important. And please remember, a limit can exist only and only if the left hand limit and right hand limit are equal to each other. Correct? Enough examples? One last discussion. Before that discussion, I will do this example for you. Find limit of f of x equals 1 over x as x approaching to 0. Guessing method or estimation method, you have to draw a table here. Here x, here f of x. This number goes in the middle, 0. For example, 3 values from the right, 3 values from the left. Start from 0.5. Here maybe 0.01. Here maybe 0.001. Here start with negative 0.5. Here maybe negative 0.01. Here maybe negative 0.001. If you plug in 0.5 here, what is 1 over 0.5? 1 over 0.5 gives you 2, right? Easy calculation. You don't need a calculator for this. If you plug in 0.01, it means move your decimal to the right 2 places, correct? It means it gives you 100. 1 over 0.01 gives you 100, right? And if you divide 1 by 0.001, it gives you 1000. Definitely here it gives you negative 2, here it gives you negative 100, here negative 1000. What do you see? What do you recognize? As you are x approaching from the right, the value of the f of x is increasing, increasing, increasing. And if I go closer, for example, 0.000001, it goes to 1,000,000. And if I go closer, closer, finally, I'll go to where? To positive infinity. When you are approaching from the left, the values are getting smaller and smaller and smaller. You see, negative 1000 is smaller than negative 100, correct? And if you go closer, 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 here your limit approaching to the negative infinity. Then I will write these steps for you. The limit of 1 over x as x approaching to 0 from right side, finally it goes to where? To positive infinity. Also, the limit of 1 over x as x approaching to 0 from the left, it gives you negative infinity. Are these two limits are equal to each other? Then you get the answer for the problem will be the limit of 1 over x as x approaching to 0 does not exist. Those of you that you remember algebra, even you know the graph of y equal 1 over x, right? And which value the denominator becomes 0? 0, right? It means x equals 0 is your vertical asymptote. Here you have your vertical asymptote. And the shape of the graph is like this for 1 over x. Remember from algebra or pre-calculus? This is the shape of the graph of 1 over x. You see, as you are approaching from the right to 0, the graph goes where? Very, very close to your asymptote, but never touches the asymptote, right? Based on algebra. That means your graph goes to positive infinity. And when you are approaching from left to 0, you see your graph goes all the way down to where? To the negative infinity. That's why you have these, right? Here you can see it in the graph. You studied in algebra, but here, this is the reason behind the vertical asymptote, correct? Now, some general notes. F, limit of f of x as x approaching to a number from left or right. I'll put both of them here, plus minus, because I'll give you a general form. Give you plus minus infinity, correct? That means that's your asymptote. For example, in some examples later in chapter, I think chapter 3, when we are graphing curves, curve sketching, there is a topic in chapter 3. We use the idea of the limit in that chapter to find the vertical asymptote. Now, you are dealing here with 4 cases, basically. You see there are 4 cases. When you approach from the right, the function can go to positive infinity or can go to negative infinity. Where when you are approaching from the left, the function can go to positive infinity or negative infinity. I'll draw all cases here for you. 4 cases. Case 1, case 2. Here I have a point A. Here I have a point A. This is my vertical asymptote here, and this is my vertical asymptote here. And number 1, the limit of f of x as x approaching to A from the right side, from this side, you can have this. Your function can approach to positive infinity. Case number 2, the limit of f of x as x approaching to A from the left, your function can go like this, again to positive infinity. Case 3, or the limit of f of x as x approaching to a from the right, your function can go like this, can go to negative infinity. You saw all of these graphs in algebra. And case number 4, the limit of f of x as x approaching to a from the left, correct? Did I cover a from the left to positive? It can go also to negative infinity. There are 4 cases, not out of these 4. You have only these 4 cases. And x approaching to a, you can go to positive infinity or negative infinity. X approaching from the left to a, you can go to positive infinity or you can go to negative infinity. 4 cases, correct? That we discuss here. This is all about one-sided limits and how to find the vertical asymptote. I will stop the lecture. 1.5 finishes here. You got the full idea of what is limit. In my next lecture, my next video, I'll cover 1.6 for you, and you see in 1.6, I'll explain the rules of the limits for you. And when you learn the rules or the laws of the limit, then solving the limit problems gets really easy. Again, please watch this video carefully or few times, because this is the first lecture of your calculus. If you understand the concept, then this class gets easy for you. See you next time in lecture 1.6.